In order to get like the 5 and the 4, you find two numbers that multiply to 20, and then you find two numbers that add to 9, and then you put them here. All right. Did you do 2?
Yeah. First, I found the greatest common factor of y's, and I brought it out to simplify it. And I got 2y minus 3, and then you have to do the same thing here with the number. I got 9, so that also gave me 2y minus 3, so I combined those two. And that makes y to the second and 9, put them into 1, and make it 2y minus 3 since they're both the same.
Common factor.
Yes.
All right. Thank you, Sam.
Here you just find the greatest common factor, which is 4, so then you can take that out, which is 4x to the 4th minus 25. And then to break that up, you just did 2x squared plus 5, 2x squared minus 5.
Okay. Thank you, Lita and Rowan. Okay, so look at number 3, class. Some of you might have a different answer in number 3, but I just checked that for now, okay? But if you're asked to simplify, it's just say factor. But you say factor and simplify, that means you have to simplify to the lowest factor, okay? Because some of you express this as 16x to the 4th minus 100. You just did this part, right? If you have a difference of two squares, perfect squares, then you do a plus b and then a minus b, right? You just did this directly given the difference of two squares, all right? So some of you did, so the square root of 16x to the 4th is 4x squared, and then this one is also 4x squared. And then the square root of 100 is 10. So you did plus 10 and then minus 10. So some of you wrote this as your answer. But again, if you're asked to simplify, that's not the final answer. Okay? Because you can still simplify this. Right? Now, so if you do this way, if you started factoring out this one into this, you can just factor out also these two factors. Right? What is the factor of 4x squared plus 10? 2. So you can do that as 2x squared plus 5. And then factor of 4x, it's also 2. So that's 2x squared minus 5. And then 2 times 2 is 4. So the final answer will be that. Okay? Which is Lila's answer. Okay, 4 times 2x squared plus 5 times 2x squared minus 5. So you can do this process. Or what Lila did, which is simpler, is she took out, because she knows that 16 and 100 is divisible by 4. So she took out the common factor, which is 4. And so if you divide this by 4, that's going to be 4x to the 4th minus 25. And 4x to the power of 4 minus 25 is also a perfect square, right? And you can do that as 2x squared plus 5 and 2x squared minus 5. So the simplified factors is this, okay? Any question? All right. Now, so today we're going to talk about these terms in your polynomial, okay? Polynomial functions. So we're entering a new unit, Unit 3, polynomial functions. So basically, this is more on defining the terms of this unit, because we're going to be using all these terms until the last lesson in the unit. Okay, so make sure we are familiar with these terms and how we can use these terms to solve problems in polynomials. Okay. All right, so lesson 3.1 is just naming polynomials and end behavior and multiplicity. So the goal here is to determine the degree of the polynomial. Determine the end behavior using the leading coefficient test. I'm just reading our goals here. And then the last one is determine the behavior of the graph at the zeros. Okay? So let's start with the definition of a polynomial. Can you read the definition? Anyone? Okay. Lila? Yeah.
An expression of a sum of terms where a plus or minus sign separates the terms. Polynomial means many terms. Each polynomial has a term number and degree.
Okay, so Again, a polynomial is an expression of a sum of terms where a plus or minus separates the terms. So you will be able to determine the term number based on, like, because it's separated by the plus or minus symbol, right? So how many terms do we have in here in this polynomial? 4x cubed plus x minus 2x squared plus 7. 4. How many terms do we have in here? 3. And in here, we have 3. Okay, so this polynomial has 4. These two polynomials has 3 terms. Okay, but can we also say that x squared plus 4 is also a polynomial? Is x squared plus 4 a polynomial? Yes. Because, yeah, polynomial means many terms, so it's more than one. But if we also write, let's say, a constant 5, can we say that 5 is also a polynomial? 5 is constant, but again, you can express any constant number into a polynomial, right? I can express 5 as 5x to the 0 plus 0, right? So I can express this as more than one term. So in general, we can consider a constant is also a polynomial, okay? All right. Now, so degree. A degree is the power of a term. So for example, if you have 4x cubed, what is the degree? 3. Now, take note that for this lesson, for this unit, we're going to denote degree as n. So if you see n, small letter n, that means we're talking about the degree of the polynomial. Okay, so what is the degree of negative 5x to the 6? 6. Now, the case for this, if you have 2 or more variables in your term, what you do to find a degree is you're going to sum up the exponents. So if you have negative xy cubed, because you have 2 variables, what is the degree of this term? 4. Okay, again, if you have 2 or more variables in one term, you have x and y in one term. So you're going to sum up the exponents. 1 plus 3 is 4. Okay. Now, let's say, what if I give you this one? You only have one variable, but then it's separated into 3 terms. Let's say 2x cubed plus x to the 5th plus 1. Because I want to highlight, what do you mean by degree of a polynomial? Degree of a polynomial is the highest degree term in the polynomial. So what is the degree in this? Yes, Imani? 5. So degree is 5. Yep. Okay. Now, standard form is when polynomial is written in descending powers of the variable. So how do we arrange or write this in the standard form? So we can start with the term with the highest exponent. So x to the 4th. What's the next term? Minus 3x cubed. And then plus 5x squared. Minus 2x, the sign is negative, yes. And then what's the last one? Plus 7. Okay. So this is the standard form of this given polynomial. So again, if you're asked to write the final answer in standard form, that should be your final answer. Okay? And then coefficient is the number in front of a term. Simple, right? So if you have 4xy, what is the coefficient? 4. If you have negative 8x squared, what is the coefficient? Negative 8. Okay. Now, we also have what we call leading coefficient. And for the leading coefficient, we denote this as A. Again, degree is denoted as N. Leading coefficient is denoted as A. Yes. So the leading coefficient is just the coefficient of the highest degree term, meaning the term with the highest exponent. So here, if you're given 7x squared minus 3x cubed minus 4x plus 6, what is the leading coefficient? Negative 3. Okay? Because the highest degree term is negative 3x cubed, and the coefficient of this term is negative 3. So the leading coefficient is negative 3. Okay? Also, I have here a table that shows the polynomial name, because when we write polynomials in lesson 3.3, then we have to know the polynomial name, okay? Because that's gonna give us the degree if we know the polynomial. And then on this side is we're gonna name the term or name this based on the number of terms. Okay, so if degree is 0, that means it's constant. And then this is only one term. And what is the term name if the polynomial has one term? Monomial, right? Okay. And then degree 1, we call that the polynomial name is linear. We know that, right? For example, x plus 1. And then the number of terms in this polynomial is 2. And what is the term name? Binomial. Yes. And then we know that if the highest exponent of the polynomial is 2, that means it's a quadratic function or quadratic polynomial. For example, negative 4x squared plus x minus 1. And how many terms do we have here? 3. And we call this, based from the term name, trinomial. Yes. Okay. Now, cubic, if the highest degree is 3 in your polynomial, it's cubic. But then why don't we have a 3 here? Because in the first term we have 2 variables. And again, to find the degree of this polynomial, we add the exponents of the variables. If you have 2 or more. So 2 plus 1, that's why it's 3. Okay? And then how many terms do we have here? We have 4. So if we're going to name the polynomial based on the number of terms, if you have more than 3, that's going to be just a polynomial. Okay? The general polynomial. And then here, I want you to know this because some students are confused with quadratic and quartic. Okay, quadratic, although it's termed as quad, and you remember because quadrangle has 4 angles on 4 sides. Now, quadratic is degree 2 based on the degree, and quartic is degree 4. Okay, so the highest power here is 4. That's why it's quartic. And then this one has only 3 terms. And so if we name this based on the number of terms, we call this as trinomial. And then quintic is degree 5. And then how many do we have here? We have 5 also for the number of terms. And we just name this as polynomial based on the number of terms. And then so on, right? So if you have more than 5, we just call it as nth degree polynomial. So let's say this is 8x to the power of 9. I call this as 9th degree polynomial, right? X to the power of 6, then 6th degree polynomial. And this one has 3 terms. So based on the number of terms, we call this as trinomial. Okay. Again, do not confuse yourself with this side and this side. This is based on the degree. This name is based on the number of terms. Okay? All right, any questions on this? All right, now we're going to proceed on the polynomial end behavior. Now, to determine the end behavior of the polynomial, we're going to use this test. And this is what we call the leading coefficient test. That means we're going to use the leading coefficient. So we should know how to identify the leading coefficient. And we'll also use the degree, the n of the polynomial. Okay? So when n is odd, meaning if the degree is odd, and then if a is greater than 0, what will be the end behavior of the graph? So we're only concerned about what happens at the end part of the graph, right? We know that the polynomial can curve many times, but we're not concerned with the middle. We're concerned about the end, right? So just think of this, if this is odd positive, think of that as an increasing graph, meaning at the left side, what will happen to the graph? It falls, right? So it falls, so that's why it goes to the negative infinity. And at the right side, it rises, so it goes to the positive infinity. Okay? And then if you have an odd negative, meaning the leading coefficient is negative, but then your degree is still odd, you know odd numbers, right? Okay, and you know positive and negative. Okay, so we're going to determine that later on. And then without the graph, you can actually use that to determine the end behavior. Okay, so think of this as decreasing graph. Okay, so which is the opposite. So this one at the left side, it rises, so it goes up to positive infinity. And the right side, it falls, so it goes to your negative infinity. Okay, so this one is rises, then falls. Now, if the degree of the polynomial is even and the leading coefficient is positive, now think of this as a parabola, right? But not actual parabola. Just think of the both sides as going up, right? So both sides goes to the positive infinity, okay? So this one goes to positive infinity. So rises and rises. And then, if you have an even degree and then the leading coefficient is negative, think of this as both sides or both ends goes down, right? So it falls, so this one goes to negative infinity, this one goes to negative infinity. So falls and it falls on both sides. Any question? We're going to use this later to complete the table, but we still have one more concept to learn before we complete our 4 examples there. Any questions? We're able to copy this part. Okay, you should have the graph in your notes.
Oh, the graph.
Yes, these graphs. Because on the quiz, which will be this coming Friday, there will be part 1 and part 2. Okay, part 1 is no calculator. Part 2 is using your Desmos. Okay, so this is part of the part 1. You don't need a graph if you know the leading coefficient test. Okay. All right, so we can practice later on, but again, that's the concept. All right, now what about the multiplicity of the zeros? What do you mean by multiplicity? Say again? Multiply, or we say multiplicity of zeros because a polynomial can be to the power of 1 million, right? So there are zeros that can be repeated. So that's what we mean with multiplicity. How many times the zeros are repeated in your function? So when you say x equals 3 is one of the zeros and it's repeated 3 times, so you will say x equals 3 multiplicity of 3, right? It's repeated 3 times. Okay. So if you have passed through, that means the 0 is just repeated once, meaning the power is just raised to the power of 1. Okay, so for example, this one, this is passed through, right? So I can write this as a factor. I can write this as, let me just write here. When you write it as a factor, that's x plus 3, right? Because if you solve this, solve for x, x will be negative 3, right? So just think of that. If that's a negative 3, if you write it as a factor, it's going to be x plus 3. And then that means this one is repeated once, raised to the power of 1, because that's passed through. Okay, this is passed through. Okay, but you have to specify at what point the graph passes through, at x equals negative 3. Okay, so this is the 0 format, or the solution. That's how you write it, right? As a solution or 0. And this is the factor format. Okay? Now, because later on we're given a polynomial in the factored form. Okay, so we should know how to convert a factor to a 0 or to a solution. And then, if your factor, x minus b, is raised to an even power, so the graph will bounce. Okay, so for example, because at this point, the graph bounces at x equals 2, I can write this as x plus 2 raised to an even power. Okay, it can be 4, it can be 6, as long as the exponent is even. So I can write this as bounce. Sorry, hold on. Because it's a positive 2, I'm going to write x minus 2. at x equals 2. Okay? And then another one, if the factor is raised to an odd power, except 1, because 1 is passing through. Odd, meaning 3, 5, so on, then the graph is going to curve. Okay? So for example, if this is the graph where the graph curves at x equals -1, I can write this as x plus 1 as a factor raised to the power of 3. So if you can see a factor with an exponent of 3, that means the multiplicity is odd. Okay? And so that's why the graph is going to curve. So I can write this as it's going to curve at x equals -1. Okay? So remember the behavior. If you're allowed to use the graph, you can check by just typing in this one on the graph. Okay? And it's going to give you those behaviors. Okay. Any question? So in our lesson 3.3, if you're asked to write the polynomial, this is going to be y equals a, because we're going to solve for a. X plus 3 times x minus 2 squared times x plus 1 cubed. Okay, that's going to be your polynomial. But on the lesson 3.3, we're going to solve for a, but that's not our goal today. Okay, I'm just showing you the behavior and what is the multiplicity if that is the behavior. Okay, so here are our examples. So do these without using a graphing utility, okay? All right, so let's start with number 1. Again, what is a value? That's your leading coefficient. Yes, so that is 2. And for the leading coefficient, we just have to determine if it's positive or negative. So 2 is a positive number. Okay? And the degree is we're going to determine if it's odd or even, right? What is the degree of this polynomial?
0.
So, okay, so 2.
Because you add both of them together and they're both 1.
Right. So this is 1 and 1, right? So if you have 2 factors, just add the powers. So that's going to be degree 2. And that's going to be an even power or even degree. So if you have even positive without using the graph, what will be the end behavior?
Positive, infinity, positive.
Very good. Yes. So think of this as like that, right? So both sides goes up. Both are positive. Okay. Now, what are the zeros and multiplicities? So if you're given the factored form, it's easier to write the 0. So if that's x minus 1, what is the 0? X equals 1. Okay? So if you don't know how we got x equals 1, we just set each factor to 0, correct? So if you do x minus 1 equals 0 and add 1 on both sides, then x equals positive 1. So or think of that as you switch the sign, right? X minus 3, x equals 3. Okay? But since on this part, it's zeros and multiplicity, so we're going to write the multiplicity as well. So since both of the factors is raised to 1, therefore the multiplicity, I'm just going to write mult of 1 on both. Okay? So you say x equals 1, multiplicity of 1, x equals 3, multiplicity of 1, because both factors is only raised to 1. And so what happens at those zeros here, at x equals 1 and x equals 3? Pass through. So we say pass through.
How do we know if it balances again?
When the multiplicity is even. Let's say 2, 4, 6, 8. And then it's curve when the multiplicity is odd. Okay, pass through at x equals 1 and x equals 3. Okay? Does that make sense? Okay, this is without using the graphing calculator. Okay? So, f of x equals -4 times x plus 2 times x minus 4 squared. What is the a value?
-4.
Okay, that's correct. And that is a negative number. And what is the degree? 3. And this is an odd. So x plus 2 is raised to 1. And then x minus 4 is raised to 2. So we add 1 plus 2. Yes. So the degree is 3. Okay, so if this is odd negative, what is the end behavior? You still remember?
Oh, negative infinity. Negative, negative. Oh, no.
Odd. This is odd negative, not even.
It's it's positive infinity, then to negative.
Yes. So think of odd negative as a decreasing graph, right? So if it's decreasing, at the left side, it rises, and at the right side, it falls. Okay? So that's going to be y. This one is positive infinity at the left, and then at the right, it's going to be negative infinity. If one of the sign is wrong, then it's going to be wrong. Okay? So what are the zeros? What are the zeros? X equals negative 2 and x equals 4. But then we're also going to write the multiplicity for each zeros. So x plus 2 is raised to 1. Therefore, the negative 2 has a multiplicity of 1.
Why is it negative 2 and not positive?
Because we solve for x. This is the factored form. When you write this as a 0 or solution, we just subtract 2 on both sides. That's why it's negative 2. And then x equals 4. What is the multiplicity? 2. Okay, so we would have two different behaviors, right? So what is the first behavior? It passed through, because of the multiplicity of 1, it passes through or pass through. The graph will pass through at x equals negative 2. And then the graph will bounce at what? At x equals 4. Okay? All right.
Still confused. I don't know if it's a bounce or a pass.
Okay, pass through if the multiplicity, or just think of that as the power or exponent of each factor. So since we know that x equals negative 2 comes from this factor, it has an exponent of 1. That's why it's multiplicity of 1. If it's just first power, it's going to be passing through. But if the factor is raised to 2 or even, it can be 4, 6, then it's going to be bounced. If it's to the power of 3, 5, 7, 9, then it's curved. Yes?
So I thought it was the 4 was a negative.
The 4, what do you mean? Like if this is x plus 4?
Yeah, would it still be balanced?
Yes, it will still be bounced because we're not concerned about the zeros. We're concerned about the exponent. So if this is like x plus 4, then the x will be negative 4. But then since the exponent is still positive 2 or even, then it's still going to be bounced. Okay? Any other questions? I will do number 3, and then you can do number 4. Okay? So number 4, we have 4 zeros here because we have 4 factors. All right, let's do number 3. What is the A value? What is the leading coefficient? Okay, 1.5. And that's a positive 1.5. So that's greater than 0. And then what is the degree? 3. And this is an odd number, right? So we got an odd positive. So what is the end behavior for odd positive?
Negative infinity to positive.
Very good. So think of this as increasing graph, right? Odd positive is increasing. So that means at the left side, the graph falls, and at the right side, the graph goes up. So therefore, as what Rowan said, this one approaches to negative infinity, and then at the right side, it approaches positive infinity. Okay? Now, what are the zeros? We got x equals 6 because of x minus 6. And then this has a multiplicity of 2. So that means the 6 is repeated twice. That's what we mean with multiplicity, right? And then the second factor is x plus 3, so that's x equals negative 3. And then since this is only repeated once, therefore we say it has a multiplicity of 1. Okay? So what happens at those zeros? Can you tell me what happens?
At 6 it bounces,
Yes?
and then at negative 3 it passes
Correct. So bounds at x equals 6, or you say x equals 6 bounds, right? It doesn't have to be, as long as the word bounds and the 0 is there, right? And then this one, pass through at x equals -3. Yeah. Okay, so I want you to complete number 4. Hold on. And then let me just save this. Stop recording.